So we're going to be looking at the Chapter 8 quiz, which is on area for the 7th grade. And again, this quiz covers both area and perimeter of shapes. So you're going to be doing some geometry here. Remember, perimeter is the distance outside the object, so basically how far you would walk if you'd walk around the edges of the object, whereas area is how much space is inside the object or how much space the object covers, which we have formulas for. Perimeter is basically add up all the outside edges if you can, and then that's your perimeter. But area you have specific formulas for specific shapes. So we'll start off with perimeter. Perimeter, again, as I said, just simply means add up all the outside numbers and see what you get. Now, the problem is, like in number 1 here, that you might not be given all the outside numbers right away. You have to do some inference there. So we need to know how big this side is and how big that side is, because we don't know that yet. Well, let's figure out this side first. We know that the entire length, so from here all the way to here, that entire thing is 12, because that's what it is down here. So this entire distance is 12. And we know that this part right here is 4 because that part's right there is 4. So if the entire thing is 12 and this part is 4, that means this part right here has to be a total of 8 because 8 plus 4 would give me 12. So you can use the edges you have to figure out the edges that you don't. Just kind of figure out what would this edge be in total, how much of it do I know, how much is it left for the stuff that I don't know. And we're going to do the same thing for the other edge too. Let me give myself some room here. So I want to know how big this edge is here. Well, I know that the entire edge from here to here is 10. That's what it says right here. So the entire thing is 10. I know that this little piece right here, that's going to be 3, because again, that's what it says right there, which means that this piece right there left over has to be 7, because 7 plus 3 would give me a grand total of 10 to match it up to the other side there. So again, you have to use the pieces you know to aid in getting the pieces that you don't. So if we erase this here. So now we have all our edges, and we can just go ahead and add them up. So we're going to take 4 plus 10 plus 12 plus 3 plus 8 plus 7. If we add all those up, we get 44 meters as a perimeter. So the actual getting of the perimeter isn't that hard. It's the tricky part is getting the missing pieces that you have in the shape. And remember, you're only using outside edges. You're not using inside edges. You're only using outside edges for perimeter. So like in number 2, we wouldn't use this 1 inch as it is because this is 1 inch on the inside. So we don't really care for that. We would do this 1 inch and 1 inch. So we're going to do 1 plus 1. That's these two sides here. But we also need to know how big this curve here is because that's part of the perimeter as well. Now getting curves is a little difficult. Now this shape right here, this top part is basically a half circle, right? If we see if we can complete it here, that'd make a full circle if I drew it out all the way. So it's just a half circle by itself. So the way you get the perimeter of half circles and of full circles for that matter is you have a formula. So circles always have formulas for both area and perimeter, or what we call the circumference. So the circumference of this half circle is what I want. So the way you get the circumference of a full circle is you do 2 times pi times r, or pi times diameter. Both these formulas will give you the circumference of a full circle, and then you can just divide it in 2 to get the half circle part. So I'm going to use this one because it matches more with what we have, because this 1 inch is the diameter of the full circle, because the diameter goes from edge to edge, which this 1 inch does, so it's a diameter measurement. So the circumference of what would be the full circle would simply be pi times 1, which is about 3.14. Now, I only have a half circle part of it, so I'm going to divide this by 2 because it's the half circle part. So basically I do what I do for a full circle, then cut it in half, and I get about 1.57. So I'm going to add that with my other two ones, and that means my full perimeter is going to be 3.57. So if your shape does have curves or circles in it, then you have to resort to these two circle formulas to figure out the curved edges, and then you can add that to the straight line edges to get your perimeter. Remember, you can use either one of these formulas. It doesn't matter which one you use the one that best fits your picture. In this case, the diameter fit better because it gave us a diameter, so that's the one I used. On the next side, we have finding the area of composite figures. So composite figures are simply when you take two shapes and you kind of stitch them together. Like in number 3 here, we have a rectangular shape and we have a triangular shape that are kind of stitched together right here. They're kind of put on top of each other. And the way you find the area of these composite figures is you simply take it one shape at a time. So I'm going to do the rectangle first because rectangles are usually easy. So how would I find the area of this bottom rectangle here? Well, the area of a rectangle is length times width. So the area of this rectangle is 16 times 6. And one thing you could do is actually write your work inside the shape you're doing. That way you know that number goes with that shape. So it's kind of a way to keep your work structured. In this case, that's 96 square meters. Remember, areas in square units. So that's the area of this bottom rectangle. Now I need the area of this triangle. Well, the way you get the area of the triangle is you do base times height divided by 2. So base times height divided by 2. Well, I got the times height part, that's 8, but I don't really have the base yet. I have this little part here as 5, but I also need this little edge piece right here. Well, again, we have to kind of use what we know about the shape here. The entire length from here to here, this entire line right here, that's 16 meters long. I know that this part is 7. Whoops, sorry. I know that that part is 6. I don't know why I said 7 there. Make that a little bit better. So I know that this part right here is 6. I know the entire thing is 16, which means that this piece that's missing right here has to be 10, which means my entire base of the triangle, because remember, I have to use the entire base of the triangle in my formula, is 15. So it'd be 15 times 8 and then divide by 2, because I want to use the entire base of my triangle, because it's the entire base times the height, then divide by 2. So again, figuring out the missing pieces and then working them in there to get your answer. In that case, that'd give me 60 meters squared again. So the area of my composite figure is simply 96 plus 60. And so if I add those together, I get the area of the entire thing, which is 156 square meters. So again, you have to use what we did on the front page to kind of fill in the missing parts of the shape here. But the big trick on this one was to remember to use the entire base of the triangle as part of your formula, not just the 10 part, because the triangle covers both the 10 and the 5, so you have to use them both when you're doing your area formula. This is another composite figure. It's composed of a rectangle and a half circle. So let's get the rectangle first. 20, which is the length, times 8, which is the width, gives me 160 feet squared. So that is the area of the rectangle. So how do I get the area of this half circle? Well, the area of a full circle is pi r squared. That's the area of a full circle. So to get the area of a half circle would be pi r squared divided by 2. Sounds simple enough. Just do the area of a full circle and then cut it in half. So let's go ahead and do that. Pi, now what's the r here? So remember, the radius is the distance from the center of the circle to the edge. So I need to know that distance. Well, I know that the full distance from edge to edge is 8, right? That's what it says over here, 8 feet. So that means that half the distance would have to be 4. So that'd be 4 there. Then divide by 2. So again, using your pieces that you know to get the pieces that you don't. Now, if you want to use 3.14 in place of pi, that's fine. That's a decent estimate. That's what I'm going to do. And you get about 25.12. Now, if you got something slightly different, that probably means you probably use the pi key instead of 3.14 as an estimate like I did. And that's perfectly fine. Just make sure you're showing your work and what you're typing in, and you should be okay. So my full area, remember, is the area of the rectangle plus the area of the circle. Don't just leave them separate. Make sure, whoops, 12. Make sure you add them together at the end. So this would be, can't write today. Let's see here. So 0 plus 2 is 2, 0 plus 1 is 1, 0 plus 5 is 5, 6 plus 2 is 8, and then 1 plus nothing is 1. So it'd be 185.12 feet squared. That'd be the total area of this composite figure. Area of the rectangle plus the area of the half circle. But again, make sure you get the missing pieces that you need in order to get the correct formulas down. And the last ones are just about basic circle stuff. So find the circumference and area of a circle with a radius of 10. So again, to get the circumference, you have two options. pi times diameter, or 2 times pi times radius. Now, since we're given the radius, not the diameter, I'm going to go with this one. So 2 times pi times 10. Now again, I'm going to use 3.14 as an approximate for pi. You don't have to, but that's what I'm going to do. And you get 62.8 centimeters total. That's the circumference. Now the area of a circle doesn't change. The area of a circle is always pi r squared. There is a formula for the diameter, but we're just going to stick with the radius here. So in this case, it'd be pi times 10 squared, which in this case would be 314 centimeters squared. Again, using 3.14 as an approximate for pi. So in this case, all you have to do is just remember the formulas. 2 pi r squared. Again, very simple formulas to memorize. Then just work with the circle. Now, number 6 is working backwards. Number 6 says find the diameter of a circle with a circumference of 22 inches. Now, there's another formula you need to know here, is that to get the circumference, remember circumference is equal to pi times diameter. Again, it's a little bit lesser used than 2 pi r, but it's still is usable. So let's plug in what we know. We know the circumference is 22. So I'm going to plug in 22 for C. Keep the pi. And I don't know what the diameter is, so I'm going to leave it as D. Now I want to figure out what the diameter is. I want to solve for D. Well, that just means I have to divide by pi. Because remember, even though pi looks like a variable, it is still a number. It's 3.14. So you can divide and multiply it just like you would anything else. So again, I'm going to use 3.14 as an approximate. And so if I do this here, the pi's will cancel. I'll be left with diameter is equal to roughly 7.01 inches. Would be my label. So if you remember this formula, circumference or C equals pi d, then you can plug in the circumference that you have, divide by pi, and get the diameter that you need. So you can work backwards given enough information as long as you memorize the formula to begin with. So these formulas here, both the area and the circumference formulas, are going to be very important to memorize because without those formulas you can't work with a circle. That wraps this video up. Hope you enjoyed the video. Have a good day.